This video, I'm going to talk briefly about refraction. What refraction is basically the bending of light when it goes from one medium to another. And you all experience looking at a straw inside a glass of water, and it looks like it's bent, right? And the reason for that, because the light that's coming to you from the water and the light that's coming to you from the air, they are traveling at two different speeds. That's why you see the bending. Now, it will travel. The light will travel slower in the water than it does in air. And here's an explanation. So I have this picture here, which is in your notes. And think of this as like you have in a, I don't know, like a toy car, right? And these are the front wheels. So, and you come in at an angle, and basically, and by the way, this refraction business only happens if you come in at an angle with respect to the surface of contact. If you come in perpendicular to it, which means at a 0-degree angle with respect to the normal, you're not going to bend. You're just going to continue straight. So this wheel here, when it hits this more dense surface, this wants to slow down, but this one wants to keep going. So this one slows down, this one keeps going, and that's why you see that bending. And we're going to do some demonstrations in class, and we're going to explain a lot of the things. Now, if you look at the picture here with the fish, basically the light, it seems that the light is coming from the fish above, which really there is no fish, and because light travels in a straight line. So, but what's happening actually is the light is coming at a different angle. It's hitting the water, and since the air is less dense, it's going to bend away. In other words, the angle with respect to this normal here is going to get bigger. So this angle down here is smaller than this angle. So when the person is looking, they're going to get the impression that the fish is above where it actually is. Okay, so I'm going to do a little bit of the math. Okay. The index of refraction is just a ratio of the speed of light in a vacuum, which is 3 times 10 to the 8, divided by the speed of light in the new medium we're talking about. So if it's water, we're looking at the index of refraction of water. Now, if you notice, this is always going to be greater than or equal to 1. Right? Well, actually, it can't be equal because you have to have 2 different media in order to have refraction. There is a rule here, and I'll explain the rule here on the side. Okay? So let's say you're going from air into some substance like water. You must be coming at an angle. You have to come at an angle, and light will bend. Now, instead of continuing straight, in this case, it's going to bend in. And I explain later why it bends in and not out. This is the angle of incidence. This is the angle of reflection. Remember, everything is measured with respect to the normal. So the law of refraction says, well, if you do the index of refraction of air, which is about 1, okay? So if I do n of the first medium we're coming from, sine of this angle here, that should equal to the index of refraction in the new medium, where we're refracting, sine of angle r. Okay? So if you pay attention to this equation, what it's actually saying, it's saying that this n sine theta product remains constant. And this is extremely important. That's going to help us figure out whether we're going to bend in or closer or away from the normal. Now, the index of refraction of water is about 1.33. For air is about 1. Now, let's explain why we bend in closer. The n sine theta has to remain constant. So if I go from 1 to 1.33, the n went up. It went from 1 to 1.33, which means in order to maintain this constant, sine of theta has to go down. And if you remember the trig stuff, the sine function is an increasing function between 0 and 90. So which means that if sine theta drops, the angle must drop. That's why this angle is smaller. If I'm going, let's say I'm going the other way. So here's my normal. So I'm going from water, I'm going to air. And I don't know which way I have to bend. I don't remember. So let's see how we can do that. N sine theta has to stay constant. Okay? Now, I go from 1.33 to 1. So I drop the n. The n drops, which means sine theta must go up so that this product stays constant. So if sine theta goes up, the angle has to go up. So the angle has to be bigger. And when I say the angle, I mean the angle with respect to the normal. So this angle here is the angle of refraction, sorry. Okay? What else we have here? Okay, and you are given some index of refractions. So let's do one simple example, actually. So let's go to page... let me see. Okay, let's go to page 11. I'm going to do number 15. Okay. So a light beam hits a sheet of glass. Now, if it doesn't say where it's coming from, we're assuming that it's coming from air at an angle of 25 degrees. So now we're going from less dense to something that's more dense. So our angle should get smaller than 25 because the n sine theta has to remain constant. Remember that. So all I have to do is do ni sine theta I equals nr sine theta r. The I is the incident. This is the refracted. So I'm coming from air, sine 25 equals nr. So for glass, I think it's 1.5 or 1.52. You'll have to look at that sheet. Sine theta r. Make sure you're in degree mode. You would divide the left side by 1.5 and either the inverse sine to find the angle.